This is the second of two videos on what policy-based management in Datera is all about, and what makes it uniquely beneficial to you. In the first video, I talked about the basics of policies and how they provide effortless consistency and eliminate configuration drift. If you haven't seen that one, you may want to go back and watch it first before this one. Here, we're going to talk about our second key differentiator. We actually combine three distinct concepts, not just policies, to implement declarative management. That would be tenancy, templates, and policies. So first, let's understand the distinction between templates and policies, because this is really important for Datera. So for us, a policy is a named set of related behaviors or configuration. It stands alone as a distinct, reusable entity that deployed storage resources can point to by name to govern one aspect of their behavior: performance, isolation, security, etc. So far, pretty standard. Now, a template is more of an overall reusable blueprint for an entire workload or application. This is what makes our storage app aware. It is essentially a higher level container or collection of configurations, including labels to policies. So not pointers to actual policies, but just labels or tags which are only resolved to an actual policy at deployment time. So just as an example, you could have an app template that defines two 1 terabyte volumes with a gold performance policy label and a tier 1 data protection policy label. Note that the policies themselves or the configuration that they represent are nowhere in this equation yet. We're talking purely abstract labels here. So this is a model or blueprint that we can then use to deploy storage resources. So here's how it all fits together. We start off with that template from our example, and we can then provision and deploy a running instance of the storage from that template. So now we actually have two 1 terabyte volumes provisioned on our storage that we can connect a workload to. But there's an additional step at that time of deployment, which is resolution of the policy labels. So now gold and tier 1 are not just labels, but they are resolved by the software to actual existing policies. Now, there's a bit of logic that goes on in that resolution that I don't want to go into details about, but one thing I'll just mention is that if no suitable policy is found with the desired label, it will always fall back to a configured default. So now these three types of entities are linked together dynamically. This is really crucial to understanding how useful these constructs are in managing your storage. So now if I update the performance policy label on the template from gold to slow, watch what happens. That will automatically propagate to the running instance. And of course, we could have provisioned any number of instances and they would all stay in lockstep, all updated to slow. And when that change propagates, the label will re-resolve to the slow performance policy, and the configuration on the running instance will be adjusted. But remember, this also works the other way too. So say that the slow policy right now is configured at 200 max IOPS, which means that's where my instance is as well. And if I change that policy to 100, that configuration change will get pushed back to my instance, and of course any other instances referring to this policy, whether provisioned from this template or any other. So notice we really have 2 degrees of freedom here, from the template and from the policy. Just to take it one level further now, let's bring in the last ingredient into the mix, which is multi-tenancy. Datera supports a hierarchical multi-tenant structure for segmenting your configuration and your deployed storage. And it turns out that the deployment and resolution relationships we were just looking at can span across tenants. So say I have a gold performance policy again in root with a 2K max IOPS configuration, and an application template that has a gold policy label on it, also in my root tenant. Now, they have no existing bond to each other right now. These are isolated bits of configuration only. So now from a lower level tenant, I can actually provision an instance from the template in root. I can see that template and provision storage modeled off of that template. At the moment of instantiation, my new instance will go searching for a gold policy to try to resolve it, and it will find it in the root tenant, so it'll apply that configuration. And again, note the bidirectional bond. Once I locate that policy, any changes on the policy will propagate back to my instance. But now let's imagine that I create a new policy, also called gold, in the subtenant, closer to the instance, with a 1K IOPS limit. So at this point, my instance will automatically detect that there is a new policy, also called gold, that is in my own tenant, and it will switch the pointer to this one, updating the configuration on the running instance at the same time. So let's take a moment to realize how useful this is. I have two policies named gold in two different tenants. You can think of these as service classes if you want. So for my root tenant, gold means 2K IOPS, but for my DevOps tenant, it means 1K IOPS. Then from the same template, an instance deployed in DevOps gets the 1K, and an instance deployed in root gets the 2K service class. So I know this is getting a little complicated. One way to think about this at a high level is that the tenant hierarchy functions like a class inheritance hierarchy in object-oriented programming, if you're familiar with that. So you can define defaults or best practices or fallbacks in higher level tenants, and lower tenants automatically inherit and can leverage that configuration automatically. But locally, tenants can sort of subclass or locally override certain configuration. So that way they can customize certain behaviors while leaving others as inherited. And because you have 2 degrees of freedom between templates and policies, the same template deployed in different tenants may end up resulting in different configurations, depending on the policy mix, as we saw in our example. So this gives you as an admin tremendous control over how your storage is configured, but importantly, in a scalable and automated way, not in a manual way. So you're using policies to set up various service classes or tiers in different tenants, where, for example, gold means one thing in one tenant and another thing in a different tenant. Then, with just one template with the gold performance label, it will automatically conform to the service classes defined in each tenant when you deploy instances in that tenant. So at the time of deployment, there's actually very little configuration that you're putting in manually. It's drawn from the template, the policy set, and the tenant context in which you're deploying. It may seem a little wacky right now, but when you're deploying thousands of instances across many tenants, you're going to find that this approach makes your life so much easier.
Learn more about how Datera brings the software-defined revolution to enterprise storage at datera.io and contact Datera for a free consultation.